Hello.
You forgot the negative!
So now we're going to talk about implicit differentiation. So usually when you're taking the derivative, you want to get y by itself and then you can just find it from there like we showed you before. But sometimes you can't do that. Like in this one, you cannot get y by itself. So you have to use implicit differentiation. So first, you want to take the derivative of both sides. So first, with the x squared, you're just going to have 2x power rule. And then the y squared is going to be a little bit different. You're going to have to use the chain rule for that one.
Why do we have to use the chain rule? You use chain rule when you have a function inside of a function. In this case, we have y, which is a function of x. You know, you have an input x and you have an output y. That function is inside of the function something squared. So we have to use chain rule.
So now, since we use the chain rule, we're going to have 2y, which is the derivative of the outside, multiplied by y prime, which is the derivative of the inside. And then on the other side, it's kind of like a product rule situation. So you got x prime y plus x y prime. And then you want to simplify all of this. So right here you have x prime, and the derivative of x is just 1. So that changes to just 4y. And our goal is to get y prime by itself, so now you're going to move things around and try to get that to happen. All the y primes on one side. So right there, I factored out the y prime, so now we can just divide that over. So the answer is going to be 4y minus 2x over 2y minus 4x.
Now we're going to talk about inverse functions. An inverse function is when we usually notate it as, say we have f of x, its inverse would be f to the negative 1 of x. It's the inverse function, meaning that if you put in x into this function, you'll get out a y. If you put in that same number, that y, into this function, you'll get out that same x. In the original function, you put in an input and get out an output. In the inverse function, however, you put in that same output and get the original input. Now, say we want to find the derivative of that inverse function. Let's say that that inverse function is that g is the inverse of f. Because of the nature of an inverse function, if you take the function value of an inverse function, it's going to be equal to the original number that you plugged into the inverse. Now, for ease of doing the math, we're going to replace the inverse function. We're going to call that g. Now, let's try to find the derivative of the inverse function. If we take the derivative of both sides, we find here we have chain rule, and the derivative of that is just 1. The derivative of the outside times the derivative of the inside, and plugging in your inner function. Now we're looking for the derivative of the inverse. That would be g prime. So, just divide by this and we have g prime.
Hey guys, so as Joe was saying, we're going to do a problem involving the derivative of an inverse function. So we have the equation right here, g prime of x, and g is also the inverse of x, so we're doing the derivative of that inverse right there. So g prime of x equals 1 over f prime of g of x. So we have the equation right here, f of x equals x cubed plus 5. And we're finding g prime, which is that right there, and also the derivative of the inverse at 4. So we're going to start by finding the innermost function. So to do that, we have to take the inverse of f of x. So now we have just found the equation for g of x, which is x minus 5 all to the 1/3. So now we have to plug in 4 for where g of x is. So we're going to start by doing this by making a table. So for g of x equals 4, we're going to plug in 4 right here. And now we have to solve for the y variable right there. So we found the g of 4 equals -1. Also, since f of x and g of x are inverses of each other, the y variable, which is -1, is actually going to be the x variable in f of x, and the y variable is going to be the input of g of x. We have just found g of x. So now we know that 1 over f prime is -1. So now, since f prime of -1 is the only part left, we have to find the derivative of the f function, which is right there. So the derivative, which we found using the power rule. So we're supposed to find f prime of -1. So now we plug in -1 into the derivative. So f prime of -1 equals 3. So now we have just pretty much found everything we need to know to finish the problem. G prime of 4 equals 1 over, we've just found f prime -1, f prime -1 equals 3, so it's going to be 1 over 3. So the final answer is g prime of 4 equals 1 over 3.
So what's the significance of all this? Let's look at what the graphs of these functions look like. The two graphs mirror each other about the line y equals x, because that's what you're doing when you find an inverse function. You're switching the y and the x value. So what we did when we found g prime of 4, we went to g at the point at the x value of 4. If you plug in 4 to the g function, you get -1 as your y value. The point that corresponds to it would be -1, 4. At any point, the slope of the tangent line of f, in other words the derivative, is going to be the inverse of the slope of the tangent line of g. You could think of this if you had a simple linear function. It would end up being g of x equals 1/3 x. In other words, the slope, which is 3 for the original, is the reciprocal for the inverse function. So we found the slope of the tangent line of the original function, which is what we did when we plugged in -1 to f prime. We found that slope and then took the reciprocal, because the reciprocal of the derivative will give you the derivative of an inverse function. And that's what we did over here. So this formula, as complicated as it looks, is actually describing a whole bunch of cool geometric truths that lie behind it.